Everyone, good afternoon and thanks for joining us during this webinar. Today we are going to be reviewing heat pumps. Thanks again for registering and participating with us. For those that haven't been with us before, this is Hayward, who we are, a little bit of the history about the company. The company was founded in 1925 by Irving Hayward, and that's where the name Hayward obviously comes from. And then in the 1964, it was acquired by the Davis family, and in 2017, it was sold to a private equity consortium. We have 10 manufacturing and distribution centers around the world, and today's presentation is geared to English-speaking, the Caribbean, and Latin America. This is a recap to the webinars that we have been having so far. Last week, we saw variable speed pumps, filtration, and gas heating. Today, we're looking at heat pumps, and then tomorrow, we're going to be looking at lighting, and on Thursday, sanitization, which is going to include chlorine generators, UV, and ozone. And then the following week, we are going to dig into automation and automatic pool cleaners. Remember that each of these webinars is an independent registration. So make sure that when you register, you sign up for all of the topics that you want. If you're participating in today's webinar, doesn't mean that you're registered for tomorrow's or Thursday. So always make sure to please keep an eye on your email, because that's how we're going to be sending the invitations. So keep an eye on your emails and register to the individual sessions that you want to participate in, and also choose whatever timing you want to participate in as well. Today we're going to be reviewing heat pumps. So we're going to do a little bit of comparison with other heating products. We're also going to see the advantages of heat pumps, especially when it comes to, compared to the competition. And then we are going to review as well with our technical manager some of the installation and diagnostics on our heat pumps. So we do have a full range of heating products. And how does a heat pump compare versus a gas heater, for example, which is always a common question from when talking to customers. They say, okay, when should I recommend a heat pump? When should I recommend a gas heater? And this is an easy way to differentiate the two heating products. Both of them have their benefits and their drawbacks. Gas heaters are very good for infrequent but fast heating. So if you have a customer that is only going to be using their gas heater once or twice a month, just for a house that they have outside the city, just for the weekends, then probably gas heating is a good option, just because you are able to heat the body of water quickly, and you are able to do it. It is not the most efficient method, but you are able to do it very quickly. So when the customer shows up and they say, oh, I want my pool to be to temperature in about 3 or 4 hours, then the gas heater is the best option, because obviously we have bigger size units that goes all the way up to 500,000 BTUs. But then the heat pumps, it is better, and it is an ideal heating method for customers that want to keep their pool constantly heated. What I mean by that is a customer that says, okay, I'm going to be using my pool every day, let it be for exercise, for therapy, or whatever, or my family is going to be using it pretty much every weekend, multiple times during the month. So then the heat pump is a better option, because the heat pump is ideal for keeping the water warm, and it is not good for quickly raising the pool temperature, because obviously the BTU capacity is not the same as a gas heater. And the other good benefit with the heat pump is that it doesn't emit any gases. So it is not like with a gas heater, where you have carbon monoxide that is going to constantly be emitted because of the combustion process. So the heat pump is also a more ecological, or a more greener product compared to a gas heater. So now we're going to take a look a little bit about the difference that we have compared to the competitors when it comes to our heat pumps. One of the bigger benefits that we have is that all of our units come with a acoustic cover on the compressor. And what that does is it brings down the noise level on the compressor, so the unit is actually very quiet compared to all of the other units in the market. We also have a bigger fan blades, and what that does is it moves all of the air that we need, but at a low RPM. So this also makes this also helps cut down on the noise that the air makes as it circulates through the unit. Another big benefit that we have is the ultra gold evaporator fin. That ultra gold, what it does, it is very corrosion resistant. So when you are installing our heat pump close to the sea, close to the beach, or you are installing it in an area with very high humidity, that ultra gold evaporator is going to have a better performance, and it is not going to corrode as quickly as you will normally see with the competitor products. And also keep in mind that all of our heat pumps also have a titanium heat exchanger. Titanium is very corrosion resistant. It lasts quite longer than standard copper. So that is another value that our units provide. Here we see a breakdown once again of the compressor cover and the blades, the bigger fan blades, in order to move all of the air. And moving all of that air also makes our unit more efficient, because remember, all we are doing is transferring heat from the air into our swimming pool. Here we see the advantages of using our ultra gold evaporator fan. After 1,000 hours of use, we can see on this test, on this picture on the left, is the standard evaporator material that most competitors use, which is basically aluminum painted in black paint. And we can see that after 1,000 hours of use, with moisture, salinity, and so on, that aluminum starts to corrode. On the right-hand side, we see our ultra gold evaporator. That ultra gold, we see that there's basically, after 1,000 hours of change of use, there's no pitting, there's no corrosion on the material, and this is what makes our heat pump last longer, especially again on high humidity and high salinity areas. And most of our markets, we are either in islands or close to the coast, to where we have both humidity and salinity. Also keep in mind that all of our heaters are made in-house, basically made in Hayward. We are vertically integrated when it comes to manufacturing of our heaters. So all of the evaporators and the control panels, all of that is made directly by Hayward in our manufacturing plants. So it is not like we are just assembling parts, we are actually making most of the gas heaters and heat pumps. And this assures that we have better quality and we are able to maintain the quality. Also keep in mind that all of the units are tested before they leave the factory. So we make sure that they are working before they are actually shipped to you as a customer. We're going to start looking into our models, different options that we have. The Summit XL, we have it in two sizes, 112 and 140,000 BTUs. And then we also have the HeatPro, which has a wide range all the way from 44,000 to 140,000 BTUs. Those units are also available in three-phase, single-phase, and we also have a heat-cool unit, which also allows us to cool the water if you live in an area that the temperature is very warm and the customer actually wants to chill the pool a little bit to make it more refreshing. Then we have a heat pump that does that as well. And then we have the HeatPro round footprint. That round footprint, many customers prefer it just because it takes less space on the equipment pad. So it is a very good option if you are a bit tight on space. And then we have the HeatPro horizontal, which that unit also in places where you don't have the vertical space in order to have a fan with the exhaust at the top. That unit with the side discharge also allows us to be a little bit more, offer more options when it comes to the installation. That unit is only 45,000 BTUs. So it is for a smaller pool, a smaller unit, that it doesn't have the same capacity as the HeatPro square units. And here we see more in depth about the Summit XL. The Summit, and remember all of our vertical discharge heat pumps they have all of the benefit that we discussed before when it comes to the ultra cold evaporator and the compressor covers. These motors, again, 112, 140,000 BTUs, and the good thing with all of our heat pumps is that they are AHRI certified. What that means is that we have a outside lab actually test all of our units and make sure that the performance is there and that we are actually delivering on the amount of BTUs that we are telling you. So both of those motors have been AHRI certified again. Then we have a HeatPro unit for low ambient. That low ambient option is good when we are doing an installation in an area that gets very cold, especially cold at night as well, because normally most of the heat pumps, they stop working at 50 degrees Fahrenheit, which is about 10 Celsius, but this low ambient unit is able to go all the way down to 40 degrees Fahrenheit, about 4 Celsius. So it gives us a greater working range for those climates that get a little bit colder than most. And then we also have a 140,000 BTU three-phase unit. This three-phase unit is great for commercial installations where we have three-phase power available. Remember that every time we are doing an installation with three-phase, the current, the power is actually more stable. We don't get the wide variations that we can get on single phase. So I recommend that every time you're doing a commercial project with three-phase, then you can use a three-phase unit, and that is going to give us less headaches, especially with power spikes and power drops and so on. And remember that we're going to see a little bit later when it comes to installation, but if we have a commercial project with a very large pool, we can actually install multiple heat pumps in order to keep those pools warm. Here we go into a breakdown of each individual unit all the way from 90 to 140,000 BTUs. And what I want to show you with this slide is again that most of the units, they cut off at 50 Fahrenheit or 10 Celsius, but the low ambient unit is able to go all the way down to 40 degrees Fahrenheit or 4 Celsius. So that is an advantage, again, when it comes to colder climates. And then I also want to show you the coefficient of performance, the COP. That COP is important because that number tells us how efficient the unit is. So in these cases, most of the units at 80, 80, 80, which we call 80 degrees Fahrenheit, 80 degrees water temperature, and 80% humidity, all of our units have a 5.7 COP. And obviously, as the air temperature drops, then our COP is going to lower a little bit. But even at 50 degrees Fahrenheit, which is the coldest that we recommend, we're getting a COP of 4.0. What that COP means is that for each kilowatt that the heat pump uses, it is able to produce 5.7 kilowatts of heat into our swimming pool. So it is a very efficient method to transfer heat into our swimming pool. And unlike a electrical resistance heater to where the formula is just 1-to-1, it consumes 1 kilowatt and it produces 1 kilowatt of heat. With the heat pump, remember the COP, it consumes 1 and it produces 5.7 kilowatts of heat into our swimming pool. And that is important because obviously that shows how efficient the unit is. That 5.7, if we look at it as a percentage, percentage of efficiency, it will be equivalent to 570%. Because again, for every 1 produces 5.7. And then on this slide coming up, we can see the power consumption, the kilowatt consumption per unit. Again, looking at that unit of 90,000 BTUs that we saw earlier, we can see that the kilowatt usage is only 4.6 kilowatts per hour. But again, we multiply this 4.6 times the COP, and it gives us the total kilowatt that it produces into our swimming pool. And then we can see that obviously as we go into bigger models, the 140,000 BTU unit, the kilowatt consumption is only 7.2. And this way, once we know the kilowatt consumption, remember that now we can also calculate, okay, how much is it going to cost for me to heat the pool? Because we can see how many hours we're working per day. Just multiply the hours times the kilowatt times the cost per kilowatt. That obviously each country has a different cost. And then that is going to give us the consumption per day or per month, however we want to see it. Also keep in mind that all of our heat pumps require a maximum amp of 60 amp, maximum breaker size of 60 amps, and the flow that it requires is 30 to 75 gallons per minute. So keep in mind, if we're installing this with a bigger size pump, let it be 2, 2.5, 3 horse, all of those require an external bypass. And our tech man is going to go greater into details on how to do a bypass and how to keep the unit from exceeding that maximum flow rate that we recommend. Also, all of our heat pumps, they have R410A. So that refrigerant that we use, it doesn't cause any damage to the ozone layer. So it is actually an ecological refrigerant. It is a green, because we minimize any type of damage that you can see with some of the other refrigerants in the past, like the R22, for example. Now going a little bit more into detail about the horizontal unit. Remember, this is a 45,000 BTU unit. The big advantage that it has is obviously allows installation to where you normally wouldn't be able to get a standard heat pump. And this unit, it can also be installed similar to like a mini split AC, to where you can actually, with brackets, you can hold it and install it next to a wall, for example. Also keep in mind that all of these units also have a titanium heat exchanger, so we don't lose anything when it comes to longevity with this unit. And something to keep in mind with these units, they will always require a bypass, because the flow rating, the recommended flow rating for this is 16 to 25 gallons per minute. So what that means is that we don't want to exceed the 25 GPM, because that is going to create too much pressure inside the unit. So it is always recommended to use an external bypass when installing this heat pump, and at the same time, always recommended with any type of heater to use a flow meter, because that's the only way that we can see exactly how many gallons per minute are going into the unit. On our website, Hayward.com, we also have a calculator that shows us the advantage of heating with a heat pump versus propane or natural gas. And the advantage is mainly efficiency, obviously. The cost to heat with a heat pump is much less than heating with gas, let it be propane or natural. And also keep in mind that yes, the heat pump costs a little bit more initially, but within 1 year of operation, the savings are going to pay for itself. And here we can see on this example, a 15,000 gallon pool, 15,147 to be exact, that we want to keep at 90 degrees Fahrenheit. We can tell whether or not the pool is planned to be covered. And then we input our cost of electricity, our cost of natural gas, or our cost of propane. And the software is going to give us a recommended heater size, heat pump size. And then it is also going to give us a breakdown per month or as a total of how much it is going to cost to keep that pool always at 90 degrees Fahrenheit, which is our target temperature. And here we can see that for the entire year, if we plan to cover the pool, remember it's a thermal blanket. If we do it with our heat pump, the cost to heat the pool the entire year is going to be $1,455. If we do it with propane, we can see that the cost is going to be $14,000. So we can see that there's a huge savings by doing it with a heat pump instead of gas. And then if for whatever reason the customer doesn't want to cover the pool, which I always recommend because that is the best way to prevent heat loss. If we want to not cover the pool, then we can see that with a heat pump is about $3,000 to heat the pool the entire year, and with propane is almost $30,000. So we can see why a cover pool, a thermal cover, is going to reduce in half the cost of heating that body of water. But by going with a heat pump, our cost is going to be basically 1/10 of what it is going with propane. So it is important to explain to the customer that yes, we're paying a little bit more on a heat pump compared to propane with a gas heater, but within a 1 year of operation, that difference is going to pay for itself multiple times. Now we're going to take a look into some of the terms that we use when talking about a heat pump, and it is some of the refrigeration terms, because remember that one of these units is very similar to what you will see with a home AC system or even with your fridge at the house. It is a refrigeration unit with a refrigerant that is doing the transfer of heat from the air into our swimming pool. We are not using any electricity in order to generate heat. We're using electricity to transfer heat. So some of the terms that we're going to see commonly is refrigeration, which is just a transfer of heat from one place to another. In this case, we are taking heat from our air and transferring it into our swimming pool. Refrigerant is the medium that is used to transfer that heat. In our case, remember that I mentioned that our refrigerant is the R410A. When we speak about cold in refrigeration terms, that doesn't exist. It is just absence of heat. We also have BTU, which obviously we're going to see that every time we talk about heating. A BTU is basically what it takes, is the energy that it takes to raise 1 pound of water 1 degree Fahrenheit. And that is important, and when calculating the amount of BTUs that we need, also keep in mind that 1 gallon of water weighs 8.3 pounds. So if it is going to take 1 BTU to raise 1 pound of water 1 degree Fahrenheit, then we can easily figure out, okay, how many BTUs do I need in order to get the job done? Condensate. Condensate is when we turn the refrigerant from gas into liquid, and when the heat is removed. Remember, that's the job that our heat exchanger does. It gets the heat from the refrigerant and it's going to transfer that into our swimming pool. And then evaporate is the opposite. Evaporate is when we take the refrigerant from liquid into a gas, and then that's when heat is added. And remember that our evaporator with the ultra gold fins, that's what it does. And then compress, obviously we have our compressor that is going to compress our gas, and by compressing the gas, it actually increases the temperature even more. Heat pump technology has been going back to 1851. It is not a new concept, and again, all of us have used it with refrigerators at our house or AC systems. Now we're using that same technology and applying it into our swimming pool. So here we see the basic process on how a refrigeration or how a heat pump works. We have our TXV valve, which we see it up here, and that valve is going to control our refrigerant flow. So our refrigerant is going to go from there into our evaporator. Remember, all of this is that ultra gold that I have been mentioning that avoids corrosion. So all of our refrigerant goes through all of the evaporator lines. And remember that the fan is the one moving the air and collecting all of that warm air in order to be transferred into our refrigerant. So once the refrigerant does that cycle, now it is warmer and it goes into the compressor. And when it goes into the compressor, remember, by that stage, it's already a gas. It's not a liquid anymore. So it is a gas. The compressor is going to obviously compress it, and it's going to increase the temperature even more of the refrigerant. Then the refrigerant goes into our heat exchanger. And it goes through inside the heat exchanger, and that's when it is transferred into the heat is transferred into our swimming pool water. So that's where the magic happens. That's where the transfer happens. Remember that all of our swimming pool water, it is only in contact with titanium tubing. It is never in contact with copper. So that's what makes the unit also last longer. After the refrigerant has gone through the heat exchanger, then it goes back into our valve once again, and the process obviously keeps repeating itself. And then during all of that time, remember that obviously the fan is moving, the blades are moving, and all of that air circulation keeps moving, keeps bringing in fresh air into the heat pump. And obviously the air that the heat pump expels through the top, it is cold air. Once you put your hand on top of a working heat pump, it is going to feel like an AC, because obviously all of the heat has been removed from the heat pump, I'm sorry, from the air and transferred through to our pool thanks to this technology. And here we see more in-depth info on our heat exchanger. Remember that all of this tubing that you see inside here, that is titanium tubing. So that is what is in touch, in contact with the swimming pool water. So it helps avoid any type of corrosion, because titanium is very strong. It's very strong metal, especially compared to copper. Next, we're going to see some of the tools required whenever we say, okay, we need to service a heat pump. Uh, like we discussed already, this is a refrigeration unit, so we always recommend you getting a certified refrigeration technician to help you with heat pumps. And because many of these tools in day-to-day swimming pool business, we do not need them, we don't have them. So it is always ideal or recommended to get yourself a refrigeration technician in order to help us out. We're going to need manometers. Those manometers are needed because we need to measure the refrigerant pressure, let it be on the high or the low, and our tech is going to go more into that. Then we are also going to need a multimeter and an amp meter in order to figure out exactly what kind of voltage we're getting on our unit and make sure that it is the appropriate voltage. And then once we have to open our refrigeration system, then we have to get all of these tools, because remember, there's no way to open a refrigeration system without the correct tools that we are going to need, including a torch kit in order to do any type of welding, a sniffer or a leak detector. We are going, like I mentioned before, all of our units are tested before they leave the factory. But remember that on the shipping process, especially when it comes to international, all of that shaking and moving can actually get something loose. So it is important to have a leak detector in order to avoid any issues or in order to troubleshoot once we have an issue. And then we're also going to need a recovery machine and a vacuum pump. A recovery machine is to before we open a refrigeration system, is to take out any type of refrigerant that we still have, because that refrigerant can actually be reused on the heat pump to charge it once again. And then the vacuum, we're going to draw a vacuum on all of our refrigeration lines to make sure that we take out all of the moisture before we recharge the unit. So again, remember, it is impossible to do service without all of these tools once you get into the refrigeration lines. We're going to jump now into our installation, and for that we're going to have our tech, Manny. He's the technical manager for the area, to help us out with the installation information. And also keep in mind that whatever questions you have during the process, please write it under the questions section of this platform, and we're going to be answering all of your questions at the end. So Manny, are you there?
Yes. Good afternoon, everybody. I hope everybody's doing well. My name is Manny Exlowak, and I'll be talking a little bit about installation and the process of it. So first of all, I want to say thank you for being with us. Let's start with installation. Installation. Let's see. Perfect. I got control over the screen. First of all, I want to tell you that all the heaters, heat pumps, actually, all the heat pumps are recommended or are designed to be outdoors. So in order to get the best out of them, the best, all the juice, the way we can say it, they need to be outside, outdoors, so they can abstract or get all the heat from the atmosphere and transfer into the wall. They are not designed to be indoors. If we put a heat pump inside of a equipment room, since it produces cold air because it's we could say it's sucking all the air from the surrounding, and then it takes the heat off that air and transfers into the water. Well, it gets to a point where the air around it is going to have no more heat. So by placing them outdoors, you're going to get the best out of them. Also, you got please keep in mind that we have to have some kind of distances. As you can see in this picture, you'll see this, by the way, in the installation manual. You can see that it has to have some kind of clearance between a ceiling, a wall, or a plant, or something that is obstructing it, so it can better work. It can breathe better. So keep that in mind, please. You can see this small example of what happened here. This customer made an installation indoors, and they had to create some kind of ducts so they can get that cold air outside of that room without making that room a freezer. Okay, because that will happen if you don't have that kind of duct. It will that little room will become like a refrigerator after a little bit, because again, the heat pump will be sucking all the heat out of the surroundings, and it gets to a point where like there's no more heat to transport because everything becomes cold. So again, this is not something we recommend. Definitely to be outside. By the way, when we see here this kind of a plumbing situation, I want to mention a couple things. First of all, it will be recommended to put a flow meter so we know what type of flow we're putting inside of the heat pump. The minimum is going to be 30 gallons per minute, and the maximum is going to be 75. So I recommend we don't put it to the minimum, because after the filter starts getting dirty, that minimum is going to become even lower. So we'll be going below the minimum, which is going to cause the heat pump to shut off because not enough flow. Now, if we're in a part of the maximum, also, I would recommend we don't go to the maximum, put some kind of bypass. I always tell customers, if you have a 1.5 horsepower pump or bigger, definitely put a bypass, and depending on the size, you may want to open it more or less. Also, want to comment here, I want to make a comment here that if we have a chlorinator, as you can see here at the end, well, first of all, the chlorinator, either a salt chlorinator or a tablet feeder, needs to be at the end of the sequence. That needs to be installed all the way to the end, because we don't want pure chlorine flowing through our equipment. It will damage our pump mechanical seal. It will damage our heat exchanger, since it's made out of metal. So make it the last thing, and also put a check valve between the chlorinator or the tap feeder and heaters. So at night, when the pump shuts off, the chlorine does not back up into the heat exchanger, accumulate, and then cause damages overnight. So put a check valve, definitely recommend it. And then here, give me 1 second. Here we can see a different kind of diagram. Also same thing, chlorinated the last thing on the equipment line with a check valve before that. And then if we have several heaters, we want to make sure we install them in parallel. You can see here that we have a line coming in. We have a suction line here from 2 main drains and a skimmer into our pump, going through a filter. And then when it comes to several heaters, it splits equally. And then we have this little valves. As you can see here, the circle with a X mark. Those will be valves. That way we can control the amount of flow that goes inside of each heater. And then obviously we'll have a flow meter so we can see how much flow is going through them. At the end, over here at the bottom, we will have some kind of bypass in case we have too much flow for all 3 heaters in this scenario. then we can open up the bypass so we can let some water flow without going through the heaters. Here you can see the red lines are the return lines from the heaters. That means hot water. They come all at the same side, and then they join to return the water or the hot water to the pool. If we want to install this heaters, and this goes for gas heaters also, either above or below water level, it is going to be recommended to adjust the water pressure switch. Now, the water pressure switch is internal. It's inside of the heater, and this switch will allow us to adjust the pressure from 1 to 10 psi. So if we have a heater below a pool, let's imagine we have a pool on the second floor, and it's a pretty good sized pool. Let's talk about, I don't know, 30,000 gallons, for example. Okay, well, if we have that, maybe that the weight of that body of water is going to make this switch close without having any flow. So we need to adjust this water pressure switch. It's got a little wheel on it. So we want to make sure is that that we adjust it so when the pump is off, the heater will not come on, will not detect flow. And then when the pump comes on, the heater will fire. So we need to adjust this switch. For any reason, if we adjust it to the maximum, which is 10 psi, and it still closes because of the weight of the water of that big pool on the second floor, then we'll probably have to install an external water pressure switch that works only with flow, not exactly with weight or pressure. And then we just install that on the low voltage line. We just interrupt the line. Okay, so keep that in mind. And let's continue with this. If we go to the electrical installation, a couple things I want to mention here. First of all, every single heater has an amperage maximum or a minimum amperage circuit. Well, every heater is going to require a minimum breaker size or a maximum. So let's do this little example. The biggest heat pump we have, which is 140,000 BTUs, requires a breaker that is of minimum 50 amps or maximum 60. So you can put either one. So what I want to say with this is that if we go with 50 amp breaker, we're going to require to have a number 6 wire, number 6 AWG wire. Okay, that wire is going to guarantee that it's big enough to support the amount of amperage, the amount of heat, so it won't burn out. Now, if we go with 60 amps, then we're going to have to go down to a number 4 wire. Okay, so follow these directions, follow these instructions. This is going to guarantee a better solution or better installation. And also, I always tell people, please follow the rules of the colors of the wire. If the wires are hot, if they're 115 volts or so, the colors need to be by code either black or red. Black and red is going to it's going to make the difference between a 2-pole breaker between the first part and the second part. So, but I mean, at least use 2 blacks or 2 reds, just so we can say that they are hot wires. As we know, neutral, it's always going to be white. In the case of a heat pump, we don't need neutrals, but the white color always means that it's neutral. And then the green one always means that it's a ground. Besides the green, always very important to put a bonding wire. Don't forget about that. Everything that has electricity, it's metal and has contact with water, needs to be grounded, needs to be bonded. 2 different things. Both of them are very important. So please don't forget that part. And if you want to use some kind of surge suppressor, also recommend it so we can protect all the boards, all the electrical, especially in all of our countries where we have a problem with voltages. We recommend we put some kind of surge protector big enough for this kind of amperage for a heat pump. And if you have any questions, please let me know. I will find out what I could recommend for you guys to install in your countries and maybe where you can buy it too. If we talk about the configuration of the heat pump has 3 buttons. One of them is so we can change from modes, and the other 2 are to make changes or to raise and lower the temperature. Now on the mode button, we have the option of being on pool mode or spa mode or both. And then we have the option of changing from Fahrenheit to Celsius degrees. Now in pool mode, the maximum you can reach or you can set the heat pump to will be 95 degrees. This is for safety. You don't want somebody to go and raise the temperature up to 104, and then later on in the week you realize that your pool is actually a spa. It's really, really hot, and you wasted a lot of energy, or in the case of a gas heater, you wasted a lot of gas. So from the factory, we said that the maximum pool can get is 95 degrees. If you want hotter than that, then you can go to spa mode and you can go up to 104 degrees Fahrenheit, which is 40 Celsius. Diagnostics. Let's talk a little bit about diagnostics. I'm going to be using a lot of pictures for this kind of presentation. It will make it a lot easier instead of doing a whole bunch of wires. But first of all, I want to tell you that if you want to know if your heat pump is actually working at 100%, you can do this test, which we call it the delta test. So what do you do with this test? All you got to do is just stand right next to the heat pump on the side and put a thermometer right next to it on the bottom or on the side of the heat pump, not on top. And then take that temperature, take that reading, and then after that, you place the thermometer on top when the heat pump is running, exactly where you see that or where you feel that cold air, and you take that temperature reading. You have to have a differential of 15 to 20 degrees Fahrenheit or 8 to 10 Celsius. If you have that, that means that the heat pump it's working at as is full capacity. The heat pump will be working, it's working at the best you can get out of it. Okay. If you don't, then you gotta see what is going on. Maybe you have a little bit of issue with refrigerant where you're a little low, or maybe the heat pump it's like right next to a wall, so it can't breathe correctly, or simply we have a lack of flow of water, and we need to pour more water into the heat pump. Condensation is going to be part of it also. These heat pumps will condensate between 6 to 8 gallons of water. It's all going to depend on the humidity of the area and the temperature of the atmosphere. Same thing with the temperature of the water. If we talk about 80, 80, 80, which is what Roberto said at the beginning, where we have 80% humidity, 80% temperature of water, and 80% temperature, I'm sorry, an 80 degrees temperature of air, then the heat pump will condensate the most. Remember, between 6 to 8 gallons per hour. If a client calls you and tells you that the heater is leaking, all you got to do is just tell them turn it off and take a look in about 2 hours. If it dry out, it's definitely condensation. If it's still leaking, then we'll probably have a leak and we got to go and check it out. But most likely, it will be condensation. Control board. They're all pretty simple. I explained to you 3 little buttons, one to jump from pool to spa mode and to change Fahrenheit to Celsius degrees, up and down arrow to make changes, or simply to just adjust the temperature we want for the pool or the spa mode. On the inside, we have a bottom part where we have a whole bunch of wires. The first little bar that we see here on the left side, it's actually labeled WS, which means water sensor, and DS, which is defrost sensor. So those are going to be the 2 sensors that we have inside of the heat pump. Water sensor will be the one that detects the temperature of the water, and the defrost is the one that is located inside of the coil to detect when the heater it's getting very cold before it freezes, it will shut off the heater, and maybe it will turn on the fan to defrost the heater. So it's part of the safeties. Then we have this color wires all over the place. The first two on the left are two black ones. These two black ones are HP, high pressure. That is the sensor that detects if the pressure of the refrigerant is normal or if it's higher than it's supposed to be. Then we have, oh, by the way, and HP, I'll explain a little bit more in advance, but most of the times, the issue with this is that we have a lack of flow. So I'll talk about that in a second. And then we have these two blue wires. The two blue wires are for low pressure. So when we are low on refrigerant, those two are going to open up and it will give us a code of LP. Most likely, we'll probably have a little leak or a leak of refrigerant, which means that we have to find it, fix it, and then recharge the heat pump. Then we have these two purple ones, which are flow. Okay, so flow will be related to the pump. Maybe it doesn't have a full prime, maybe it's off, maybe it's not working, or simply we have a dirty filter or a valve on the wrong position, or maybe a complete open bypass. So that's the kind of things that we're gonna have to look at. Two yellow wires here are for the compressor. These two are the ones that send the voltage to the contactor so it can close and send voltage to the compressor so it can turn on. That's 24 volts that go out. So if we want to see that, if they're working or not, simply turn on the heater and then make sure the contactor is closed, and you will see it in a second. Then we have this black and brown wire. That is not low voltage. This is the only exception. That's high voltage, 115 volts. That is to turn on your fan, the fan. So if we have a fan that is not coming on when it's supposed to be heating, we can take a look there, make sure that we have 110 going out, and otherwise troubleshoot the fan or the capacitor. Then we have this little empty spot that you see guys here. This is a connection only for units that also cool your water. So for heat cool units, you will have a reversing valve and it will be connected right there. If you don't have a heat cool unit, then pretty much that spot is going to be empty since we have no reversing valve to energize. Then after that, we have two more wires at the end that these are the 24 volts that come from the transformer to the board to energize the board or the controller. And at the end, we have this little green bar with two little wires, and on top, I know you can't see it because of this little red bar, but on top it says PS. PS means pull and spa. If we connect this heat pump to automation, we will use a two-wire connection, and that's where we'll do the connection on the heat pump. So again, if the heat pump it won't start, the screen is white, what do we have to check for? Make sure we have 240 volts coming into the contactor. If we don't, then we have to go and see the breaker. Make sure the breaker is on, make sure the breaker is okay, make sure the cables are okay. If the heat pump, it's still, it still has a white screen, but we do have 240 coming in, then we got to make sure that the transformer's got 24 volts going out. So just double check those two wires that you see there, the blue and the yellow, and make sure you have 24 volts. If you do have 24 volts and the heat pump, it's calling for heat, then this is the contactor. And on the sides, that's where you have to check, just make sure that you have 24 volts coming in. If those 24 volts are coming in, that contactor should close and send the voltage to the compressor. Here you see the 24 volts, it comes from the transformer to the board, and then the two yellow wires are going to be the 24 volts that go to the coil of the contactor. So if we have 24 volts going to the contactor, 240 should go out of the contactor to the compressor and the fan. Here you see the rest of the codes, but I'm going to break down into pictures. So first of all, again, you have 24 volts coming in. You have a contactor that's got 24 volts on the coil that closes the contactor and sends 24 volts out to the compressor and starts the unit. If for some reason the unit does not start, but we do have 240, before you jump into conclusions, then the first thing we can do is check the capacitor. The big one, as you can see here, is for the compressor. We need to disconnect that, make sure that we have enough microfarads or capacitors in it. We just got to check that with a voltmeter, special voltmeter that checks for that kind of units. Before you check that, make sure you do a short circuit on it with a screwdriver or something so we can take the load off of it, because they will be charged for a while even though if they are disconnected. And then you have this little capacitor, which is the one for the fan. Same thing, short it out and then check for capacitors, make sure you're good. Every single one of the capacitors has a number of UF, which is what it's rated for. Now for the compressor, it's actually going to be not 30, it will be something like 80. So when we check for capacitors, we need to make sure that we have close to 80. If it has nothing, then we know it's definitely bad. And a different way to see it also, if that capacitor is kind of blowed up, like inflated or something, then we know that it's also bad. If for some reason the capacitor is good, but the compressor still won't start, then we gotta check the connections. You can see here the connections where the plug comes in. It's got 3 little plugs, 3 little pins. We wanna make sure they're not corroded or burned out or melted. So if everything looks good, then we can check and make sure that the compressor, it's not grounded. And by checking this, we need to have a voltmeter, check for continuity, and then we can go from ground to each one of these pins. And if we have continuity with one of those pins, we know that compressor is shorted out. It's bad, it needs to be replaced. It burned out. If you get the code of HP, which means high pressure, again, the most common issue with this, it's lack of flow. So before you start taking refrigerant out of the heat pump, before you do that, if you have no gauges, I will definitely check the flow, water flow. Okay, if we have a little bit of flow going through the heater, the refrigerant will overheat. Well, the pressure will go way higher because there's not enough water cooling down the flow of refrigerant, and that will give you that code. So we need to put more water into the heat pump. If we have LP, low pressure, one of the reasons could be because the compressor comes on, but the fan will not come on. So in that case, let's check voltages, check the capacitor, and maybe check the fan. The fan could be bad or is stuck. If everything looks good, then we're gonna have to jump into a problem with leaks, refrigerant leaks. So most commonly, this code will be related to a low pressure or a leak of refrigerant. But if you have a fan that is not working properly, then we can start that way before we jump into looking into leaks in the whole 9 yards. Water temperature sensor and evaporator sensor, the way we can check them to make sure they're good in case we get one of these codes like OP, COP, PO, DPO, etc. What we could do is check for ohms on the sensor. We disconnect the sensor, check for ohms, and depending of the water or the temperature of the water is going to depend how many ohms we have. If we're not close to that number, the sensor is definitely bad, or if it's open, definitely bad. So as you can see here in this chart, if we have 85-degree temperature on Fahrenheit, we should get a reading of 8.249 ohms. So if we're not close to that, we definitely have a bad sensor. And if it's open, definitely a bad sensor. And almost at the end, flow, the code flow means water flow. We have a problem with flow. Most likely the things we gotta check here are, sorry about that, give me 1 second. Sorry. Okay, so flow. So the problem here with flow is going to be related to a pump. Maybe it doesn't have enough prime. Maybe the pump is not on. Maybe the motor is not working, or a dirty filter, or a valve in the wrong position, or maybe a bypass that is completely open. And last will probably be our flow sensor. These flow sensors are really good sensors, so the possibilities of them failing are not that great. So I will definitely look outside of the box before we replace a sensor. Another thing, the hose, the little hose that is connected between the heat exchanger and the sensor, sometimes could be clogged up with a little bit of dirt or something. So we can disconnect that little hose and then turn the pump on and make sure that the water spits out of that that little hose, and then connect it back in. So again, flow, definitely look outside. Okay, and last, expansion valve. Unfortunately, the expansion valve will give you either one of these codes, either high pressure or low pressure, depends on which way the manometers move or which one moves quicker. But in order to know if the expansion valve it's bad, the only way to know this is by putting gauges. The gauges will tell you when the expansion valve is stuck closed and it's just not working anymore. And what happens is, for people that know how gauges work, when the heat pump is off, it's going to have a stabilized pressure. For example, the low pressure will be at 150 and the high pressure will be at 150. But when the heat pump comes on, the high pressure one will tend to go all the way up to the maximum, and at the same time, the low pressure will tend to go all the way to the minimum. So they will go to opposite sides. When we see this with manometers, we know that definitely the expansion valve is bad and needs to be replaced. Now, today we have expansion valves that you can remove the little head here. You just gotta untwist it and then twist the other one back in. We will recommend that you bring the pressure of the refrigerant a little bit lower than normal, so it'll be a lot easier for you to push it or to install a new one under pressure. And then this little cylinder that you see here, which is the one that is attached to the tubing, to the copper tubing of the refrigerant, is just to be pretty much swapped for the old one. So you can do that without doing a lot of welding and or soldering with the copper of the unit. So that will be the last one. And to finalize, I will have Roberto here talk to you about a summary of the whole presentation, and then what we have in the future for you guys. Thank you.
All right, thanks, Manny. Just as a recap, remember the options that we offer when it comes to heat pumps, all the way from 44 to 140,000 BTUs. The big difference between us and the competition is the ultra cold evaporator. And also remember that our units are quiet because all of them have, first of all, large fan blades with low RPMs. And at the same time, they also have lower uh, acoustic cover, I'm sorry, on the compressor in order to minimize the noise. Remember to join us for our upcoming webinars as well. Today we did heat pumps, and tomorrow we're going to be doing lighting and water features. And then on Thursday it's going to be sanitization. So keep an eye on that. You should have received the email already to register for those webinars. And remember that each of the webinars is an individual registration. So just because you register for the one today doesn't mean that you are automatically registered to the other ones. You need to go in and register to those that you wish to participate in. And then keep an eye on your email for next week in order to do automation and automatic pool cleaners. If you have any questions, this is the time, please, to write it under the question section of the app. My email and my contact information is right here, Roberto Sablon, sablon@hayward.com. And then Manny Ixlawak is our technical that also presented all of the installation information. So feel free to get in touch with us if you ever need any help. And let me see if we have any pending questions. No pending questions here, so that's good. It means that the information was clear enough. So we appreciate your time and thanks for joining us and hope that you can join us tomorrow. Once again, have a good day. See ya.
Thank you guys.